Hi gents, we're going to go on to question or exercise 4F here. So this now comes right to the end of relative velocity. This one is substantially more difficult than the ones that have gone before it, and of course they enjoy asking it when it comes to the questions on the leaving cert. What am I going to suggest here? Yeah, you really need to know your trigonometry. If you don't know your trigonometry, we're in a little bit of trouble here. So what you might do is you might just drop me a message just saying, yes, this was absolutely fine. Yeah, we knew all that trigonometry, or no, maybe you might explain that as we go along, or make a separate video. I'll try to do some explanations of the stuff as we do it. Okay. Starting with 4F, what we'll do is we'll start with question 2, because I know that some books question 1 is actually different. That's come up before with the group that I have. So we'll start with question 2. There's more asked in question 2 anyway. So this is something called the T method. A girl wishes to cross a river which is 50 meters wide. So I will say to you that your diagram here is all important. Okay, so this thing is 50 meters wide. In a boat, the river flows with a speed 2 meters per second. So she's going to be probably heading off in this direction. Okay, and then the water will be bringing her down the way. The girl wishes to land on the opposite side at a point which is 120 meters downstream. So that means from where she started, so that's the other point over there. What she really wants to do is she wants it so that she'll actually end up there. Okay, so she'll head off in this direction over left. She'll get swept downstream, and she wants to land at 120 meters. So this is 120 meters between there and there. Okay, and the question then is, what two directions would she have to steer the boat in, and find the two times of the crossing. So there's two directions in which you can steer the boat, which will make this work. Okay, diagram, as I said, is going to be all important. What's also important is to say that T is the time taken for the whole crossing. Time taken for whole crossing. Okay, if that really is the time taken for the whole crossing, then since she is traveling at what? She is going at 1 meter per second. Okay, so if it's 1 meters per second and she's going for t seconds, then obviously this distance here, and it is a distance, is going to be t. In the same way, going the whole way from there to there, the river is flowing at 2 meters every second. So if the whole thing takes t seconds, then that distance is going to be 2t. So that's 2t up there the whole way. Okay. What do they typically do? They typically give these angles names. They call this angle A, which is also angle A. They call this whole thing angle B, and they call this one angle C, which is that. Why is that so? Because we've got parallel lines, and so they are alternate angles to each other. Okay, you see the diagram can fill up pretty quickly, so you just got to be quite careful as you're going along that you know exactly what's happening. So maybe let's just use black here. First thing I would do is I would go and get what is D there. I would go and get that length. So you'll be able to see that D is part of a right angle triangle there, and we know two of the sides, so that's pretty simple. So we have 120, we've got 50, and we've got D. And in fact, if you know your main triangles, that's meant to be a right angle, you know that the 12, 5 and 13 triangle is there. So if that's 120 and that's 50, we can just go straight to saying that D is 130, but Pythagoras' theorem will get that for you if that doesn't jump out to you. So D is 130 meters. So this is a good start to getting it. Okay, now what we want to do is we want to set up something called the sine rule. But in order to do that, what we want to do is we want to also get what the angle A is. Okay, so we now know what D is, we know that 50 and 120, so you can use any sine, cos and tan that you want. I'm just going to use tan, since tan will always work there, since the opposite is 50. The adjacent is 120. You know, it doesn't rely on us getting the other one right. Not that we would ever get it wrong. So it's the tan inverse of 5/12. I'll just type this into my calculator. Okay, so it says that A is 22 point, we'll say 62. We'll do to 2 decimal places. 0.62 degrees. So we now know what A is. A is that. So I will actually fill this in. 22.62 degrees. I'll also fill it in down here for the sake of 22.62 degrees. That's what we know what D is. D is 20. So we may as well just fill in stuff as we go. Okay, we're now going to use the sine rule. So if I just put in the bits that are important to us, we know that this is 22.62. We know that overall on the top we've got 2t. We know here that we've got t. And we know here that we've got 20. And we know here that we have b. Okay, here's what we're going to do. We're going to use the sine rule here. The sine rule to use, we know that that's angle C. It might look like we should say something like, so I presume you know the sine rule. In case you don't, just a 30-second thing. So something that's true. If that's side A and that's angle A, if that's side B and that's angle B, if this is side C and that's angle C, it's true to say that A divided by sine A, so that is any side divided by the sine of the angle opposite it, is equal to any other side divided by the sine of the angle opposite that one. And it's also equal to, therefore, any side divided by the sine of the angle opposite that one. Make that a small c, just to differentiate between sides and angles. Okay, so I am assuming that you know that that's true. Things that we know this angle here, so we could say that t, so a side divided by the sine of the angle opposite it, so t divided by sine 22.62 is equal to, now just think about it here, if you say 20, and it is tempting, over sine c, there are two things that you don't know here. There are two things that you don't know, and you can't solve both of them at the same time. So although 20 is tempting, it's actually not the one to go for. And even more surprisingly is then when I say, well, what's the only other side that we could deal with? It's 2t, and it's over sine b. And that looks even worse, because now we have, you know, two things that we don't know. Again, and we've got a t involved another time, but actually that's perfect. Because t is on both sides of the equation, you can divide both sides by t. So instantly this just becomes 1 over sine 22.62, and on the left hand side we just get 2 over sine b. And now all of a sudden there's just one thing that we don't know. So that's the sort of thing you kind of have to memorize, that technique or that plan, because it might not be something that jumps straight out to you. Multiply both sides by sine 22.62 multiplied by sine b. So both sides by that. On the right we get sine b, on the left we get 2 sine 22.62. And that is fine. So let's go and figure out what that is. So 2 sine 22.62, make sure you're in degrees mode. So we get that sine b is equal to 0.769. I'm going to say it like that. It's not a bad idea, in fact. because these things are relatively sensitive. It's not a bad idea just to go and write it out as accurate as what you can. Okay, here's where some issues arise. People forget, and maybe if you haven't done trigonometry, I'm going to have to explain this to you. In order to get what b is sine inverse this thing here. So I'll just call it a and s because that's what I'm going to use on my calculator. So I'll do sine inverse of the answer that we just got, and that for me comes out as 50.29 degrees, we'll say something like that. But there is another answer, okay? If you place that angle in there, if you do sine of that, you will get 0.769, blah, 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 but there is another angle that will work, okay? So let's just think about this. I hope that you've done trigonometry. If you have, then this will not be news to you, but I suppose I can't take that risk. So here's what we do. We'll put in 50 degrees, 50.29 degrees. Okay. What that tells us is, remember that this is made up of an x value and a y. There's x, there's y. It's made up of an x value and a y value. And you'll remember that it's cos theta and sine theta. Okay, so what this says is that if we go to 50.129, this is the unit circle, that's 1, 0, 0, 1, etc. What this says is that the sine of 50.29 degrees would read off and give us a value here, a y value, a height value, that height there, of 0. I'm going to say 77 just because I certainly am going to fit in this number in there. That angle there will give us a height of that. But is there another angle? If we swung this arm all the way out here, this would also give us a y value of 0.77. Okay, so if you swing it all the way there, well, because these things are symmetrical, this will be 50.29 in there. But the question is, what did you do to go all the way there? Well, obviously the whole way here is 180, and we're only going back 50.29. So the other value for b is equal to 180 less 50.29. So there are two values for b, and we'll get this one now. 180 minus 50.29, and that comes out as 129.71 degrees. What I suggest you do is this. I suggest you press sine of that number 129.71, press equals, and see does it give you this, and it does give me that almost exactly, other than the fact that I've rounded very slightly. So these are our two values for b. Okay, those are our two values for b. So we go back up to our highly cluttered thing here. I'm going to get rid of this thing here actually, because it's not particularly useful for us anymore. And I've already forgotten what the number is. 100. Sorry, yeah, we have to take two cases. We got to take two cases here. So we go with 50.29 first. Okay. What we want to do now is maybe just draw out this triangle down there. I'm going to try to remember 22.62. I won't be able to remember. I'll just go back up to it. Okay, 22.62. We know that this is 50.29. The top bit, as I recall, was 2t. This bit was t. This was 130. Maybe I can't remember it. Okay, and then the question just becomes, what's this angle here? So we can work that out. Just 180 minus the 50.29 minus the 22.62. Okay, so this comes out to be 107.09. And now look at this, we are ready to go. We can just use the sine rule again, but not a problem. We'll say t, take this side divided by the sine of the angle opposite it, t divided by sine 22.62. is equal to, and now use the thing that we know. We know 130 and we know the angle opposite it, 107.09. So we get t is equal to, and this maybe we should say is case 1. Case 1, which is that b was 50.29 degrees. So here we get 130 sine 22.62 over sine 107.09. Oh, we've actually already answered the first one, which were the two directions in which we could go. Well, those are the two angles that you would need. You can put your own direction on it in terms of, you know, we go west, west 50.29 degrees north. So you can say that. Let's just get what t is. So 130 sine 22.62 over sine 107.09. So if you don't close the brackets on the new one, it doesn't do it for you automatically, apparently. So we have t is equal to 52.31 seconds. That's what we end up getting. Okay, 51.31 seconds. And if we do case 2, do it beside it, case 2, which is that our angle there is 129.71 degrees. Okay, we'll draw in our triangle, very much not to scale, very much not to scale, 22.62, 129.71, but it doesn't matter, 2t, that's still 130. Okay, so again, we go get what the angle is here, 180 minus 129.71 minus 22.62 is 27.67. Just having doubts about the 22.62, thankfully that's right. Okay, that would have been not good. Okay, that's what we're dealing with, and again, it's just the sine rule. We know that that one was t. You could use it with 2t and then, you know, 2t and this one here, there wouldn't be a problem setting it up there, but then there's just a little bit more work to do. So, us being efficient, we'll just do this. And that side is 130, and it's over sine 129.71. So we get t is equal to 130 sine 22.62 over sine 129.71. If you still have it in your calculator, and I don't, that would have been handy to be able to do that. So 130, just to change out the numbers, 130 sine 22.62 over sine 129.71. Press equals, and this one here takes us 64.99 seconds. I'm going to say 65 seconds. Okay, and there we go. We got our two answers for it. We might just have a little talk about what angle were we talking about there, because it is worth just mentioning. Okay, remember what B was, what A was, and all the rest. So A was 22.62. So we'll take our two options here. We'll look at the two cases. One was that B was 50.2. Hold on. Was that 50.29? It was, yeah. 50.29. Yeah. Sorry, I was just remembering the unit circle, which was our issue there. So let's see what we would say here. That's 50.29 added to 22.62, and we'll do 180 minus that answer, telling us that this is 107.09. So forget what I was saying there about direction. It was worthwhile just actually going and doing this. So the direction, you know, in which they should head is going to be west 107.09 degrees north. Okay, based on standing at that particular point there, that is what they should be doing. And our other case again not to scale, 22.62, and what was this guy? This was 129.71. Oh yeah, of course we already had got that there, so that's handy. 27.67 degrees is what we would say, so the direction in which they should head is west, 27.67 degrees north, based on that. Okay, so there you have this, kind of done it. We'd already got that, but this was, this was part 1, if you like, and this was part 2. So we got those two numbers there, and we got those there. So those are the two directions in which the girl can steer, and the 2 times of the crossing. I see it says the nearest second. So t is equal to 52 seconds, and t is equal to 65 seconds. Okay, you can see that there's a lot more going on in there than we've had of most things. It's really just trigonometry. There's not a whole lot of, the velocity of one relative to the other, that sort of stuff. It doesn't really come up in this. It's more just, trigonometry, triangles, clear diagrams, 2 sine rules, and just solving it out. But I would suggest you just learn that little technique, because you could be faffing around for a while trying to figure it all out. I mean, you will get there in the end, but as you already know, time is a serious issue. Let's just have a little look here what we say. Okay. You know what? I will pause it rather than wasting your time, and I'll pick out one for you to do. Okay. Just having a look at it, I think question 5 is a pretty reasonable question. It's very similar to the one that we've just done there. So if you stop, pause, go back, redo question 2 along with me, then you should be well set for question 5, just to see whether you can do it on your own. Okay, gents. I hope you're keeping well. All the best.